So today I will be talking about question 4. We need to be able to show that the area of the shaded region is 1/4 of the area of the whole circle. To do so, we first need to find the area of the sector subtracted by the area of the triangle and the small segment CD. So for area of the sector OAB, what we first need to do is use the equation 1/2 times r squared times 3 pi over 4. And this is the equation used to find the area of sectors. And remember to make sure that your calculator is in radians as well. Next, for the area of the triangle OAB, what we have to do first is to use the equation 1/2 times r squared times sine 3 pi over 4. And this is the generic area of a triangle equation that we can use, which gives us √2/4r squared. Now for the area of segment CD, this one actually requires 2 steps. Now finding the area of segment CD requires 2 steps. Segment OCD minus triangle OCD to give us the small segment at the end. Now for sector OAB, we use the same formula we used before to find the area of sectors, which is 1/2 times r squared times pi over 4, which gives us r squared pi over 8. Now for the triangle, we use the formula for finding area of a triangle, 1/2 times AB times sine C, and this one gives us √2/4r squared. Now it is time for us to pull everything we've learned and found out together. We've already found out the answers to all of these different sections, so now we can write it all out and calculate it. Remember not to leave out the brackets for the small segment CD that involve 2 steps. So this is what we have if we open up all the brackets, and as you can see, the √2/4r squared actually cancel each other, which gives us the final total of pi r over 2 divided by 4. Now we just need to summarize our proof, and I know it actually went out of the screen, but you can use the 2 symbols to show that you have succeeded. This is the next question I'm going to talk about, which is also a proof question. We can begin by first breaking down the left-hand side by writing it out and transforming the secants and the cosecants into cosine and sine squared theta. Then, like any other subtraction, we make it a common denominator and expand out with the numerator. As for the right-hand side, we know that tangent equals sine theta over cosine, so we can use that to help us expand. Now you need to remember to look for patterns that you notice within this one and than the formulas you created with the left-hand side. And you will be able to notice that the sine 4 theta minus cosine to the power of 4 theta actually can be factorized to create this. Further than using an identity that we already know, we can actually cancel out the sine squared theta plus cosine squared theta. Now we are able to prove that both sides actually equal each other. The final step is to write out the actual proof and summarize it to show that both have the same results on the left-hand and right-hand side.